Hello, everyone. My name is Juan Ramirez, and it is an honor to be here at the Maple Conference 2025. Today, I present Educational Digital Twin for microchip design in Panama using Maple and MapleSim. This project is a key piece in the effort to prepare the next generation of engineers in my country, Panama, and other Latin American countries and support, in the case of Panama, the national semiconductor strategy. I hope you enjoy this journey to the frontiers of mathematical technology. To introduce the project, I want to highlight the central objective. Our project aims to support Panama's national semiconductor strategy by developing an educational digital twin focused on microchip design and simulation, utilizing the powerful tools of Maple and MapleSim. It is an innovative response to current educational challenges, driven by my passion as a Maple ambassador since this year 2025. Panama has been identified as one of the seven key countries to strengthen the global semiconductor supply chain, with the vision of becoming a regional hub in this industry. According to Dr. Eduardo Ortega from Senacid, National Secretary of Science and Technology of Panama, the key areas of opportunity for Panama are clear: supply and logistics chain, semiconductor design and assembly testing, and packaging ATP. Our initiative focuses directly on strengthening the design area through education. The context shows us a great ambition for Panama to become a regional hub for semiconductor development. However, STEM education fields face significant challenges, such as school closures, strikes, and crucially low accessibility to specialized microelectronics laboratories. This is where Maple Tools offer a potent solution, serving as a digital platform to bridge complex theory with engineering practice. Allow me to share my background. I have I have been a STEAM YouTuber since 2017 and was named a Maple Ambassador in 2025. Through my channel, I have produced over 335 educational videos. As a self-learner, I have advanced significantly in microelectronics designs using precisely Maple and MapleSim. My personal experience validates the power of these tools for advanced self-learning. My YouTube channel, which has an audience of students across Panama and Latin America, has focused on physics topics and has over 1,000 subscribers. It is my platform for disseminating knowledge, and it is now the main vehicle for integrating Maple tools into engineering didactics, taking the learning of basic science to a more accessible and visual level. We are currently in the intensive learning phase of Maple and MapleSim. The next phase is the most exciting, building the functional educational digital twin for teaching microchip design. To ensure relevance and impact, we already have institutional visits planned with key stakeholders in Panama, such as IEEE Panama, Senacid, UTP, ITSE, and private partners. This is where the magic of the didactic integration happens. To explain the complex behavior of internal currents is in an idea, ideal diode the diffusion current and the drift current. I first use an animated drawing to illustrate the movement of charges and the electric fields at the p-n junction. This provides immediate physical intuition, overcoming the limitations of lab access. Once the conceptual basis is established, we move to the Maple tool. Here we solve the differential equations that govern these currents, such as the continuity equation and Gauss' law. Maple allows us not only to calculate but also to visualize the mathematical dependence of the total current as a function of voltage and material parameters. This establishes a fundamental didactic bridge from conceptual animation to mathematical rigor. This slide illustrates the evolution of my own learning and application of MapleSim. What you see here is the simulation of an operational amplifier, a basic component in electronic engineering. MapleSim allows us to model and simulate these systems with an intuitive graphical interface, selecting analog components. Crucially, I am now beginning to replicate this learning and application process with students from electronic engineering and mechatronics engineering at the University of Panama. This transforms the teaching of circuits, allowing them to experiment with complex designs without the need for an immediate physical laboratory, accelerating their comparison and practical skills. The future vision and impact are immense. We seek to provide direct support to national education and research in microelectronics. We want to foster student motivation with cutting edge STEM tools and, above all, create scalable teaching models based on the MapleSim digital twins. This is key to democratizing microchip design education. In conclusion, this project is an innovative and strategic solution for Panama and other Latin American countries. By using the Maple and MapleSim digital twin, we overcome current educational challenges, accelerating the development of Panamanian talent in the semiconductor design and ATP. Our vision is clear: to train the next generation of professionals and, in doing so, position Panama as a regional hub in the microchip industry. Thank you. I'm now available for any questions.